Hey folks, welcome back. Are you struggling to deploy your AI agents to a distributed, scalable, secure, and observable platform due to its indeterministic natures? I'm Ken. I'm a senior software engineer from Amazon MQ. My primary focus is actually ActiveMQ, so I work with Matt and JB a lot, and they give pretty good talks on ActiveMQ. But I also do different initiatives. So for instance, Gen AI. So I've been exploring how we integrate message broker into Gen AI architecture. And today I'll present an open source framework that we developed to help address those issues. And last night I checked with Ignash. Unfortunately, he couldn't make it. And he's using this framework to write an agent in case this happens next time. Yeah. So a quick overview of what we'll talk about today. So we first go into, for those of you who are not familiar with what MCP is, we'll do some knowledge primer on MCP and see some demos. And then we'll go to the key ideas of this talk. I'm going to use AMQP as a transport. And finally, we'll have some Q&A. So what's MCP? Well, to understand MCP, we first need to understand what AI agent is. And for those of you who don't know, AI agent is basically just a glorified while loop. At each iterations, it asks users for input. It then goes to the LLM to decide the response and what to do next, and then just return that result. But it also has a lot of other things like tools, for instance. So for those of you who work with LLM API before, it has this field that just take in a JSON of like what tools it can invoke. And then what those tools does is it basically provides the LLM context about this session. So LLM all trained with some sort of knowledge cutoff, right? So if you want to use it for your internal data or up-to-date data, you need to provide them with additional context. You can also provide them with additional context to guide its trajectories. And of course, the agent itself will also invoke those on their behalf. So those tools can be a Python functions, it can be an API service, etc. But that can quickly lead to a problem. It sounds so amazing and good, but if everybody start writing their own sort of like algorithm or how you encode the tools and how you can invoke the tools, it can be not really portable. We solved it with it's a classical software problems, and we solved it before. So last year, Anthropic released MCP, which is I think Model Context Protocol. But basically, the key value of it really is to standardize how an AI agent interact with its resources. So its problem, its tools, and its other contexts, etc. So from here, you can see now with MCP, the developers can just use the MCP protocol to develop a set of tools. And then that will be worked across all the AI agents using a client. And some of those MCP server can be providing data from data lakes. Some of them provide some dev tools, and some other connect to a SaaS. And AI agent is just consuming over a standardized interface. So at the core, MCP is just a protocol that passes messages between a client and the server. And all those messages are JSON RPC encoded. So, and the protocol also defines, what to do when you first establish a connection and how to interact with those resources. So, for instance, this example here you can see is how a client would invoke a tool. So it passes the ID, the version of the RPC, the method. Basically, this method think of as like a command. And then what argument to call with. And the MCP in this case provide like a standardized a schema, again, the ID, RPC, and then the result, which then, depending on what's being invoked, gives you a different one. So to see an MCP server in action, our team earlier this year open source 2 MCP server, one for ActiveMQ, one for RabbitMQ, and this one's for RabbitMQ. And for this particular MCP server, we basically wrap the admin HTTP endpoints with MCP tools such that an AI agent can just call those endpoints and get those contexts, and then with its own intelligence, plan and executes. So that allows developers or sysadmin to manage the fleet with just natural languages. So for those of you who operate RabbitMQ before, you might know there's broker definitions. To provision some resources, you have to edit the JSONs. But with that approach, everything can be done by natural language. So in this demo here, I just tell it to connect to a broker host on Amazon MQ for RabbitMQ using OAuth. And once it establishes a connection, I just tell it, hey, what's up with this broker? What are the statistics on this broker? And it gives me all the resources and sort of things in a nice, readable manners. I then tell it to, hey, can you just add a topic exchange and a few other bindings? And it just, with natural language, it just does that. And then it tells you, oh, I added all this exchange and queues and the bindings. And then I ask, oh, OK, is it done? It can tell me what's changed, what's out. And all that really simplifies how one can manage RabbitMQ broker with natural language. So that's just an example of how you how an MCP works and what it does. But let's dive a little bit deeper. So how does MCP do that? How does message actually being passed between client and server? So there are two transport that are supported. Standard I/O being the first one that launched last year, also the most widely used one. It just basically used the OS standard I/O. So a client just spawn a process and then bind it to the standard I/O and just read data from there. So it's meant for just like quick testing and development, no authentications, scalability because it's like one-to-one, and then it's not very suitable for enterprise deployment. But this field, if you work in AI, it moves really fast. So they seem to be really successful. They exploded, everybody running MCP. So in June, they launched a new transport ship out of the box called Stream of HTTP. Basically, the message are now being transported over HTTP. So you don't have to host both your MCP server and client on the same host. You can actually host the server remotely. And then the message are being passed by HTTP, and you can also add authentication on top of it. So by default, it's secure by OAuth 2.1. But it also has its own drawback. HTTP being just a poll base, it's just not really suitable for asynchronous operations. So then, our team just go back to the drawing board and we start brainstorming, how we can help the situations. And we already built an MCP server for message broker. Can we flip the logic around, use message brokers in MCP? And we came up with this idea of basically using AMQP as the MCP transport. And I think it's quite good ideas. And well, first of all, why AMQP? Well, I mean, AMQP is being an open standard, and AMQP 1.0 is adopted by many brokers. So ActiveMQ supports AMQP 1.0, RabbitMQ supports AMQP 1.0, other brokers as well. But by actually having a message between the client and server route through a message brokers, we can pull the complexity down. And we know how powerful those message brokers can get. And we can then achieve all this property in a production environment, such as resilience, observabilities, analytics, and securities. And all of this are happening at the transport level. So the clients and the servers, they don't have to know. That means you can just grab a popular open source MCP, plug it into your mesh, and it just can start communicating and get all those benefits for free. So how does it actually work? So by putting the complexity down, we are basically using the message broker to route the messages. In this implementation, in V1, we are using AMQP 0.9.1, but we are actively working on AMQP 1.0 support. But it basically, the message all go through a topic exchange. The MCP server, when it's connected to this protocol, it will advertise you specify an exchange and also the server name, and then it will bind to a specific routing key. So, for those who are familiar with RabbitMQ routing keys, topic exchange, that's how you get the message routed there. And you bind a queue to that exchange. And then when the MCP clients are connected to the mesh, it will then say, I want to connect to that MCP server and specify its own exchange as well. So if that exchange are equal, they basically connect to the same topic exchange. And the MCP client will then send a message to that routing key, also specify in the message header which routing key to reply to. Then the protocol itself will go back to that and manage all the sessions for them. And that is already really beneficial because with a RabbitMQ or any message broker, they support QoS, right? So the messages are persistent. So that means, for instance, let's say the MCP server just fell and goes down, the messages are still there. Once they go up again, you can just read that messages, right? Error handling, DLQ, ship with most of the message brokers and configure the policies, and etc. Also, flow control. You know, if there's too many clients connecting to the MCP servers, you can do some pushback. But also, it's pretty easy to scale because MCP server just connect to a binding a routing key, and if you want to scale up the number of MCP servers serving this requests, if there are a lot of clients, you just add more MCP server binding to the same routing key, and all the message will basically multiplexing the workload, and that has a lot of benefits already. But more importantly, actually, the real juice of this framework is you don't have to specify them to be the same exchange. The client can connect to its own exchange, and then the MCP server can connect to its own exchange. Of course, the message will not flow from one to the other, but then you put in something I call interceptors. Basically, it's just an application that look at that exchange messages, do some processing, and then forward it or reject whatever to the server exchange. So that is really helpful when it comes to observabilities and analytics, because if you wrote an AI agent before, you can tell us sometimes the agent can call multiple tools over and over again, and then it can go very long. We call the agent trajectories. And we want to get visibility on that, see if are there any rogue agent running, or are there more, which tool are being used the most. With all those analytics, we can do performance tuning, right? Because AI agent itself, because the non-deterministics, if we realize an agent always follows the same trajectory, then you basically have an algorithm out there for you. You can just write your own code. You can using some code generations, whatever, just write it as packaged as one tool. Then you can just batch process them. Or if you realize that it's actually going too long, then you're probably going to do some sort of prompt engineering. So analytics of how the agent is doing is the key. And with the interceptors, you can also fan out to your own event-driven architecture. So if you're already using a message broker for your other workload, whatever, you can plug it in easily as well. An extension of this idea is how we make sure we deploy AI agents safely. And what I mean by that is all the foundation model out there has been jailbreak. I'm sure you read the news of how you can get LLM to talk very toxic stuff, right? And we cannot trust the safety mechanism built into the LLM itself. We need to do our own guardrail. And in this case, right, you can have an interceptor that just read the messages and then see, how are the tools being used? And you can build your own guardrail on top of it. Say, for example, if a tool being called says get web search result, do some sort of web scraping MCP server, and this person is constantly asking how to make bombs or something like that, then you can then stop it or denial list that client. And because every message has to first route through interceptors, you have the kill switch that you need to denial list individual client or just shut down the whole system if something has gone wrong. And that usually is integrated with some sort of SIEM, security event, event management, stuff like that. And really, you can just write anything to go between the two exchange. So to realize those ideas, our team actually developed a open source framework called MCP-enabled transport. It has 3 main components in there. I have a QR I'll code at the end, so you can over the code yourself. The first is a TypeScript SDK for developing MCP servers and client natively that just talk over AMQP. And that will then, give you probably the best performance and more readable. However, I realize a lot of the MCP server client out there are not on AMQP. So how do we make it go on this framework? We also develop adapters that bridge standard I/O to AMQP. So you can have a MCP server running on standard I/O on top of that adapter, and then all the messages will being translate from standard I/O and just put it to the AMQP, the message brokers. Same on the client side. So you can just grab anything that's existing and just run on this framework. And finally, to get to those requirements, we also have the interceptor SDK, which let you write your own interceptor. So it, you can write it to OpenSearch. You can write the data to S3 or whatever data lake of your choice. So to further demonstrate these ideas, let's imagine a company called Any Company. It's building an agentic system for their customer, and basically their use case is I want my customer to do academic research. It's like this chatbot, one of those chatbot startup. And the users basically just go onto their UI, say, asking questions, and then the back end of this system will then spawn a agent with each of the requests, and then a whole bunch of MCP servers. So for illustration purposes, let's say they use the archive MCP, which is just looking up papers on archive. Also Firecrawl, which is just a web scraping, open source web scraping services. So they use this tool to gather the context, the up-to-date news of what you're searching about. But being like big companies, they need requirements demanded by enterprise, right? So first they need to gather analytics, right? Like they need the metrics, to prove that is this really working, and then all this stuff, and also make sure it's safe, right? Because what if someone is trying to use this to do academic research on malicious activities? So what they end up using is this architecture. So what they do is they have a Kubernetes cluster of all the MCP server that they can just find on the internet, and then they use the adapter so that they don't have to change the code or anything. Same do on the client side as well, which is Strands, is the one that developed AWS for writing agent. Then they basically connect all those MCP server to this MCP server exchange, and all the clients connect to this MCP client exchange. And in between them, there are interceptors, which I just mentioned earlier, is also deployed in the Kubernetes clusters. And the first one, analytics, is the one that write down all the messages to OpenSearch, and then the safety is doing the same thing, but it actually prevents, for example, what if you find a very large paper that just flood the context window, then just render your AI agent useless, or some sensitive keyword that can just filter out. And they will all write to OpenSearch as well. And since all the message are just routed through all this exchange, the client and the server, they don't have to know this exists. So you can have multiple teams working together, right? So the AI researcher, who are very good at doing prompt engineering or whatever, they can just work on that without knowing all the infrastructure. And the infra team, who is in charge of provisioning all the resources with more aligned with the traditional software engineering skills, can work on the clusters and the interceptor implementations. So just to show, you will see a video as well, but this will what look like on OpenSearch. So without changing any code in the client and server, they will get all these metrics for free. So sorry for the cutoff there, but you're supposed to see how many tokens are being used in each messages, how many client has been served, how many MCP servers are in the system, number of interactions back and forth, and the total number of messages. And in there, get a nice breakdown of what are tools being used in the your agentic backend. You get the trajectory depth and then see what the top 3 client they use the most, because the industry is shifting to more like how we do long-running agent and all this stuff. And then you can have some, I just call it security metrics, which is like, oh, how many messages exceeded the word count, total count, and then the rate limited. For example, you cannot call more, you cannot have an agent trajectory depth more than 20. Of course, 20 is a small number just to show you, but in reality, like 30, 40 is normal. But of course, you have something like 100, then okay, then maybe there's something wrong. So here's a quick demo of how it works. If you look at the topmost terminal, that is the agent, the UI part. The middle one is the open search, where you can go into logging it into the open search class, the deployment. The last one is where the interceptor, the safety nodes. And you can see it start doing some cool things. So I asked it to, just run the agent. Now the open search one starts intercepting all the messages and then pipe it to the open search deployment. I asked it, can you find me papers on quantum mechanics? Now, quantum mechanics of course has lots of fields, right? Of course, AI doesn't know it, just like call them MCP tools. But you realize, hey, it exceeded my limits because the return result is more than 600 words. And in my safety nodes, I say, okay, if it's exceeded that, transform the message, say it's too much. Then you can tell that the agent knows that, okay, got a message saying the context is too much. Can you specify a target search? So say, okay, quantum field theory, so, right, a sub-branch of quantum mechanics. But hey, it's still exceeding the limits. And then they will say, okay, well, just find one paper, right, that can get me lower than that limits. And as you can see, it does the job. And then this is the dashboard that is showing the demos. So before we end up this presentation, I want to end with a key takeaway is MCP over AMQP really simplifies the development and deployment of a large-scale enterprise agentic AI system because of the flexibility offered. You can write pluggables, interceptors to meet the needs, and can just grab any sort of open source MCP server and client and just plug it in. And a final food for thought is, right now the MCP is more like a sync operation. It's just the agent asking, I need this context, give it to me. But what if we can do something more async? Now the keynotes, the more nuance with that term. But can we push context, right, to the agent? So in that case, HTTP is no longer that useful. And pursuing this direction using a message broker between MCP client servers can open up a new world of exploring developing AI agents. I linked with the QR codes. The first one is the MCP server I demoed earlier. The second one is the key, which is the MCP-enabled transport SDK. That is in beta and is in active development. As I said, the next step is to support AMQP 1.0. And then the last one is the deployment demo, which all the Kubernetes cluster and stuff like that. This is also available on NPN, so you can just NPN install it and just try on your own as well. And I would encourage all of you to contribute. Yeah, that's it. Yeah, I think I've a few minutes for questions.
Yeah, we got a few time for some questions.
As the chair of the OASIS AMQP Technical Committee, I'm ecstatic about this.
Awesome.
This is absolutely fantastic. I'm just like, how can we get this work into a neutral place that is not just Amazon, but where without antitrust and how this all works, right? So in Apache or in the CNCF or better even in OASIS, but it doesn't have to be OASIS, so that we can all work on this together, and then we can go and walk up as AWS and Microsoft and the Rabbit people and the ActiveMQ people to the Anthropic and other people and say, here's the official blessed AMQP binding for MCP. So I would like for us to all work together on this so that we can go and tell the AI people, the messaging people are unified in trying to support your thing, but you support our thing.
Yeah, no, that's very good ideas. And yeah. And Charlotte's right there. So yeah, awesome. Maybe one more question.
Any other questions?
Thank you for the talk. It's not so clear to me how the MCP server capabilities are announced.
So could you repeat
The
your question?
capabilities, how is it discovered by the clients?
Oh, so the discoverability is an interesting concept. So right now, the client need to specify like what server you want to connect to. So if you write an AI agent, you specify what MCP server you want to connect to, right? And then that's how it knows which binding, which routing key to subscribe to. But that said, right, it's all in the message broker. If they can just say, for example, I trying to connect to an imaginary MCP that does not exist, it was still trying to send that message over, right, to that routing key, but there's nothing on the other side. But once that thing go online, then it can take that message and process it. But there was no sort of way of saying that, okay, I just connect to this mesh and it give me all the MCPs available. That said, everything is possible. It's just code. We can like change it. We can extend it. So yeah, that's a great idea.
Got time for one more question?
You said you're working on AMQP 1.0 support.
Yeah.
Why is that important?
Yeah, well, because AMQP 091, the most adopted by RabbitMQ and I think another 11MQ, right? But AMQP 1.0 is just have more adoption. So ActiveMQ, for instance, supports 1.0. RabbitMQ supports 1.0. I'm sure other brokers support 1.0. So by choosing 1.0, we just have more brokers, more agnostic of what the broker engine being used. Yeah.
All right, let's give Ken one more round of applause.
Thanks, everyone.